Hey guys, welcome again. This video would be about different programming paradigms that a software architecture must know because the way we think, code, and solution a problem can be highly influenced by a programming paradigm. Now, programming paradigms is a way to put programming languages into different categories based on the features they have. I think it's imperative to know the major programming paradigms in use these days so that we can choose the appropriate ones before working on a problem or the next project. It has been so many years I've been working as a software engineer and always putting on hold to learn about programming paradigms. Finally, this time I got my chance while learning, and I'm glad that I learned because so many things got clear which were unknown before. And I hope you will also learn something new today. But before that, let's see what you will get when you go online to learn about it.
You will find many confusing terms online like imperative, declarative, procedural, structured, functional, logic, object-oriented, and many more. And what do all these even mean? If you Google programming paradigms and go to the Wikipedia page, you will be surprised to see that the list is huge with lots of different paradigms mentioned there.
Not only this, some paradigms do not have clear boundaries or there is a thin line of separation. I went through blogs, videos, and papers to understand the important terms that I will share with you today. I will try to explain as clearly as possible without any confusion. So let's start. Now, we all know when we write a program, there are two things to consider: what we need to do and how to do it. What we need to do is a must thing because you need to know what you are going to implement.
When we only mention what to do, then it is called a declarative paradigm. But if we mention what to do plus how to do it, then it is called an imperative paradigm. Declarative contains what part only, but imperative contains what plus how part. Now, in case of declarative, the how part is left to the language implementation. Language internally will process the what query that we have given. Let's see an example of each one of these. Let's see an example of imperative paradigm where we mention what and how part. Example, we want to get top 10 students alphabetically whose marks are more than 90. So we have some student data which contains name of the student and marks. So we will go step by step. First one is to read data. Second is to filter out students whose marks are more than 90. Third would be to get only top 10 students. And finally, we will sort students alphabetically by name. So in imperative paradigm, we have mentioned the how part, how to solve the problem step by step using these four statements. If we try to solve the same problem using a declarative language like SQL, we will write something like this. So we have provided a what query that this we want to do. We haven't mentioned any how step, how we want to do it. So we are saying that give us all the students where marks are more than 90, sort them by their name, and only give us the top 10. So we have provided a logic, a what query, but we haven't mentioned how to do it. So the language internally or the SQL internally will handle it for us.
Now we will look into each of these two terms and their subtypes. Let's look into the first one, which is most widely used these days, the imperative paradigm.
Okay, so now we are done with the top level where we have imperative and declarative paradigms. Now we will look into the imperative paradigm. Let's start with the one which is kind of foundation of all, the procedural paradigm. The basic concept behind this is to sequentially execute instructions in a program until the program is completed. The instruction can be an assignment expression, it can be a function call. So the idea is to divide your bigger problem using smaller functions that can be reusable. The functions can be called from the main program or from other functions. The data usually stay in the main program, and these procedure or functions work on this data to solve the problem. Let's see an example. So we have a small script here that reads students and marks data, add marks to students, and finally publish mark sheets. So we read data from its source, then we have some procedure or function calls to help us create the solution. So for example, we add marks to students, calculate position of each and every student, sort students by position, and finally publish those score sheets. So this is kind of a procedural program where we are going in sequence, so solving a problem using smaller functions. It is true that it might not always be possible to go in a sequence. Sometimes we have to take what we call jumps. For example, let's take this. In case of if-else condition, we might have to sometimes skip some code or to choose only the one which is required at that time. In case of while or for loop, we finish the loop, then start again from the first line, then go into the whole program and then start again. But the most confusing and dangerous of all, which is kind of not used these days, is to jump anywhere in the program. For example, many languages supported go to statement in the past. So we can have label like this in, for example, label X, and then we can use go to statement to go to that label. So we can jump to any line the program using it. So based on these jumps, procedural program is again divided into two small subsets. Let's see. So we have now seen what is a procedural paradigm. And based on the jumps that we just discussed, it is divided into two types, structured and non-structured. Let's look into these. Let's first look into the structured paradigm. When a program is made using only a sequence, selection, and iteration, then it is following a structured paradigm. Sequence is just a way to execute the program line by line from top to the bottom until it is completed. Selection, as we just saw, is if-else conditions where we skip some lines or choose appropriate line to execute based on some condition. And finally, iteration is just to repeat lines until a condition is met in case of for and while loop. So if a program only contains these three, then we say that it is following structured paradigm. On the other hand, in non-structured paradigms, we have statements like statements. With those statements, we can jump to any line on the program and can execute that line. So these statements are missing in the structured paradigm or are restricted in this paradigm because it becomes hard to test programs or to divide program into submodules if we have these unintended jumps. So the program is structured when it contains only these three and non-structured when it has certain statements that can help us to jump anywhere in the program. Okay, so we are done with the procedural paradigm. The next to look into the imperative paradigm is the object-oriented. Let's look into this one. Object-oriented is one of the most widely used programming paradigms these days. There is no clear definition of what makes a language object-oriented, but let's see the most commonly used one. A language is an object-oriented if it contains the functionality of encapsulation, inheritance, and polymorphism. If a language contains all these three, then that language can be called an object-oriented language. Let's look a bit about these and I will go into the details into another video. As we saw the example of procedural programming, we saw that the data usually reside in the main program and the functions that work on that data are usually separated from it. But in case of object-oriented, encapsulation provides us with a way to bind together data and the functions that work on that data. So when we create such definition, we call those classes. And when those classes come into memory, we call those objects. So again, encapsulation is a way to bind together data and the functions that work on the data so that those two are isolated from the outside world. Inheritance is a concept when we want to use the functionality of an existing class and want to add more on top of that. So for example, as we saw, we have class definitions in object-oriented languages. For example, here we have a base class. And if we want to extend that or use its functionality and add more on top of that, we can create what we call a child class. So child class will inherit the base class and it will have all the functionality of the base class. But it can also add more onto that. So this concept of extending a class is called inheritance. Polymorphism is one of the most powerful concepts in object-oriented paradigm and is a bit difficult to understand. It provides us with the functionality to use the same interface to invoke different behavior at runtime. For example, we have an interface that is pointing to class 1. So interface is kind of a blueprint and class 1 is the implementation. Now it can happen that the same interface can now point to class 2 instead of class 1. So we don't need to change anything. So for example, there is a caller that is using this interface to call some methods like get and save. He doesn't need to know that the implementation has been changed from class 1 to class 2. The interface will now start pointing from class 1 to class 2, but the caller will still be calling the same methods. So polymorphism provides us with this functionality to change to point to a different base classes based on the requirements. Okay, we have completed the imperative paradigm with object oriented. Now let's look into the declarative paradigm. I will not be going into much details about this paradigm, but we will look into one which is functional programming. It is getting a lot of popularity these days. So let's look into that. Let's look into a concept called first class citizens functions. In functional programming, it is kind of a requirement that functions should be first class citizens. But what does that mean? It means that a function can be passed as an argument to another function, or a function can be returned from a function. Again, so in functional programming, all functions should be first class citizens. So they can be passed as an argument or they can be returned from a function. Another concept in functional programming called pure functions. So a pure function is a function which when passed the same arguments will always return the same result. So for example, we have a function here sum which takes two arguments a and b and it will return the sum of a and b. So whenever we pass the same parameters a and b, it will always return at the same result. For example, when we pass 10 and 15, it will always return as 25. So sum here is a pure function. Pure functions are used widely in functional programming. They do not modify the data and they always return the same result when the same arguments are passed. We also have a concept called composition in functional programming, where we combine several small pure functions to solve our problem. So we take the result of one function and use it as an input to the next function, then take the result of that and pass it to the next function, and so on. So for example, we have a function called first class, which when given students return as students who has marks more than 90 or those students which are considered first class. Then we have a function that takes students and return as the name of those functions. We can combine these two functions to get name of all those students who are in first class. So this way we can combine several functions in functional programming to solve a problem. So the concepts we have seen so far, we can use those to write code in a functional paradigm way, which also seems like an imperative paradigm. So what's the difference between these two, functional and imperative? So let's see an example. If we want to find sum of numbers in a list in imperative paradigm, which is pure imperative programming, we can find the sum using this, where we declare a variable through the list and add every list element to the sum and finally return the sum. In a functional programming, we do not need to mention the concepts. If you remember, in functional is a declarative paradigm where we do not mention the how part, we only mention the what part. So in functional paradigm, we will write it something like this, which has a function. For example, this example is taken from a JavaScript language which has a function reduce, which using which we can give the what query. We do not need to mention how to calculate the sum. We just give the logic to it, and reduce function will automatically internally handle it for us. So in functional programming, we just give the what query, but in imperative programming, we mention the how part also.
Okay, we are done. Hopefully, you would have learned something new today. I will be going into details about some of these paradigms into the next videos. If you liked, please subscribe and share. Thank you.